All right, so we're at the February 21st practice. So by the time you get to here, you should have already done your liftoff for Legends of Learning for this week. And hopefully you've attempted this and you're coming back to check and then make corrections from that. Okay, no reason to not attempt this before you've watched this. Okay, so sorry, I just didn't get my notability up first. All right, you note. All right. All right, so here we're doing this somewhat odd thing where we're balancing equations with hangers. Uh, but I think it makes pretty good sense once you look at it. So we're looking for all the equations that represent the hanger. So here we have 3x's, right, equals 6 ones or 6 little squares, right? So, all right, so that would be x plus x plus x, and then the 6 ones right there. Okay, so that one's right. So this is 3 times x. This x 3 times equals 6 ones. So that works too. Then 3 times x equals 6. There's that, right? And then, oh, sorry, this is not my fault. That's x times x times x. That will be x to the third power. All right, so that's actually wrong. Okay, apologies. All right, then this x plus 3. This is not x plus 3. It's 3x's. And then x times x times x again will be x to the third power. And these are not times 1. That would be 1 to the 6th power, which equals 1. All right, so it is actually just A and C. All right, next one. Write an equation to represent each of the hangers. Okay, so here we have 2 x's. All right, so 2 x's, and then we have 3 ones. So I see that as 2x equals 3, right? Or you could have said x plus x equals 3, like that, right? That would have worked also. Second one, we got 1.3 plus w equals 2.7. Or you could have said w plus 1.3 equals 2.7, right? Here we got 3 y's, or y plus y plus y equals 5.1. And on D, we have z plus 1/3 equals 1/2. Okay. All right, number 3, right? The equation represent this hanger. So we have 2 x's, or x plus x equals 14.62. All right, so now how are we going to reason through this? Well, we got to take this 14.62 to get it down to the x's. We'd have to, basically divide those into 2 parts, right? So we would need to divide into 2 parts. Okay. Andre says that x is 7 because he can move the 2 ones with the x to the other side. So he said, I'm gonna move them over here. That's not correct, because what you would need to do, so that should be no, right? Because that's a completely different equation, or something like it's saying that we have the left. I would say something like this. You should have your own wording here. Is x plus 2, and then the right is 5. So therefore, if you move those 2 over there, that completely changes the equation, right? It would make the right too heavy. All right. Match each equation to one of the diagrams. All right, so here, so m is going to be equal to 12 plus 4. All right, so 12 plus 4 equals m. All right, so we got, so if we go, so m minus 4 equals 12. That would work right there. Okay, that would be this one. So if you took this m, you subtracted 4, you would get 12. think that would work. All right, so here we got so we have on C, for example, we got M divided into 4 parts gives us 12. So that would be D right there. All right. Then here we got 12. When we did 4 times M, we got 12. That would be this one. All right. So then, all right. So M minus 4 equals 12 was there. Then 12 minus M equals 4 would be there. Okay. All right. Here, the equation that matches this, we got 3 x's, or x plus x plus x, and then 4 ones. So that would be 1 plus 1 plus 1 plus 1, or 4, right? So 3 x's equals 4, right? That would be the same thing. All right. Now, this is cumulative review, right? So some stuff from earlier in the year, since I didn't have really the space to do a full weekly review, I got to start working some of this stuff in. So we're going to draw the label, the square, and label each side. Hopefully yours looks a little more square-ish than just rectangle like mine. Okay. Okay, now the perimeter of the square would be, so another way of writing this would be, for example, 4 9x minus 6's, right? And so if you do 4 times 9x here, you get 36x, and then minus, and then 4 times 6 is 24. All right, a survey of 50 coffee shop customers, if I could talk, asked what their preferred type of drink was. 17 preferred lattes, 14 regular coffee, 8 cappuccinos, and 11 mochas. So it's out of 50, right? So we're looking for regular coffee right here, out of 50, because 50 is the total, part out of whole. And we should know that percents are out of 100, right? Therefore, 50 is times 2. This is times 2. So that's 28. So 28% is the percents out of 100 prefer regular coffee. Okay, next one, we have the ratio of those that prefer cappuccinos to mochas. So cappuccinos, right? So this is cappuccino over mocha, right? Cappuccinos to mochas. So cappuccinos was 8, right? And then mochas is 11. You could have written it that way, could have written it that way, or you could have written it that way. And then if there were 150 customers, how many would you expect to prefer lattes? So we had 17 out of 50 who prefer lattes. So if there were 150 customers, you should see that that is times 3. Do the same on the top. So 17 times 3. So that's 21. That's 51. So you would expect 51 to prefer lattes. Make sure you got all that work shown and turn it in on Canvas.